Hey everyone. So I hope you all enjoyed your little refresher on Linux, and you should have in your previous lab gone over the Git application, which is what you will be using as a version control tool. It is commonly used in coding so that you can work amongst multiple teams on a single project, and it just keeps the changes that multiple individuals are making to the actual code project from actually conflicting with each other. So as we start to now move into learning about Python and the scripting language, we'll start to use Git, and you'll actually be putting that tool to work as we start to kind of build our skills. So this week we're going to actually be getting into Python, covering what it is, the scripting language, why we're choosing that for software-defined networking. And in this module in particular, we'll be going over the fundamentals and the different elements that you would commonly see in Python. So this is going to be your introduction to Python for software-defined networking. Our objectives for this lecture are going to be to go over the Python language fundamentals. We're going to cover the Python interpreter, which is just a way for you to be able to practice coding. Kind of creates a Python interactive environment where you can run, in specific commands, similar how you would in Linux, or you can paste code in there and verify that everything's working and that it's not going to error out when you actually go to run your script. We'll be looking at Python packages, what they are, and how we can use them to as a way to better code some things that we may want to do by leveraging code that people have already created. And then we'll be looking at the different elements of Python variables, the different types. There's a few different data set types in Python that we're going to be covering, each with its own syntax and its own use case. So we'll be covering that as well. And then finally, we'll be getting into flow control, otherwise known as loops and conditional matching. All right, an overview for this lecture, we're going to be covering Python and, just covering why it's been the language of choice for software-defined networking, why Cisco chose to focus on it in the DevNet Associate book. And then we'll be covering the interpreter, how you can use it to help you to learn to code and just learn different things in Python. It's a great place to go experiment with the language and see what works and what does not work as you get more and more familiar with the syntax. Virtual environments, that's become the de facto on how people are working with Python, and amongst multiple groups, it keeps our project very lightweight, and it affects it from affecting our actual native installation of Python that's on our core operating system. We'll be covering variables, the different types, how we declare them, and how they can be used in Python. Lists is one data structure in Python, so we can create lists of variables, or we can declare the variables directly in the list. So we'll be covering the syntax of that, and then how we can further use lists will be also covered down in our loops and conditional matching. We're going to cover dictionaries, which are key value pairs, sort of similar to lists. You'll find that when we covered lists, that everything's called by an index number, whereas in dictionaries, everything is referenced by a key value pair, and you actually call the values by calling the specific keys. That's probably, I would say, as more common ways that we're going to see that in software-defined networking, because dictionaries are basically a direct representation also of JSON, which we'll be covering in a later module. Tuples, which are a little less common, I feel like those are usually declared in the core code base. They're pretty much exactly the same as lists, but the biggest difference is tuples are immutable, so you cannot change the value of a tuple once it has actually been declared. We're going to be looking at a couple of built-in functions and then the purpose of functions in this module. I'm actually kind of covering some material more than once so that I can really re-emphasize it, and as you work through your labs, and you'll notice that I'm having you do a lot of repetitive work, and that is so that you can practice, because I just noticed a lot of people were not practicing in my previous courses. That way when they get to the end, they're really struggling to complete, like the final project or some of the more advanced coding that we're going to be doing, because they didn't take the time to actually practice on some of the base fundamentals. And when it comes to learning a programming language, it's very important that you have those base fundamentals down and then you just kind of build on top of them. Then we're going to be covering if statements. I have taken a Java class, so I'm trying to remember how if statements are written, but in Java, but basically what those are is if a condition matches, then do something, else if this condition matches, do this, and then so you have if, else if, and else statements that you can use together, and we'll be looking at how we can use those for conditional matching. We're going to look at for loops and how we can use it to loop through different elements in a list and perform different tasks to those elements. We can also nest if and else if statements in our for loops. And then we'll be looking at while loops, which executes when a condition exists and as long as that condition exists. We'll be kind of covering as well how that can actually lead to big problems, because if you're not careful about what you're doing, you can create what's called an infinite loop where your code is just sitting there running over and over again, and it's stuck in that loop. It's not a big deal. We got ways that we can actually get out of it, but it is just something to note as you start to work with while loops, that you can potentially create an infinite loop that will just go over and over again, and how to get out of it. And I will be doing a demo of a lot of these technologies at the end, so we'll be covering some examples in the Python interpreter, and hopefully that gives you a nice place to start with your labs. As you read through your labs, you can also reference the demos that I'll be covering. And then finally, we'll be moving into the summary. All right, so overview of Python and why Python. Well, for one, Python is multi-platform. What does that mean? It means that you can run Python, it does need to be installed on Windows, you can run it on Linux, you can run it on Mac. Basically, anything can run Python across multiple platforms. Even the newer models of Cisco devices and some network devices offer the ability to run Python natively on there. But another really great use case for Python is the use of packages, which we're going to be covering in a later slide. And what that is just kind of pre-built code, but we can use these packages to interact with network devices via SSH. A little background on how I got started with Python. When you're learning a programming language, I do like to kind of reference it as though you're learning another language. I like to use those as similarities because I've been working with Spanish for a very long time. So it's very important that you understand it's kind of a journey. It's not something that you can learn quick. You have to practice. You've got to continue practicing. So what got me interested in Python was when I was just starting out in networking at more entry-level work, I would have a lot of repetitive tasks that were given to me. And at the time, I was also exploring some different security features and penetration testing. So I ordered these things called a bash bunny and a rubber ducky. You can look them up. But what they are, they're USB tools that you can insert into devices. And then as soon as you insert it into a device, you've programmed it to enter certain keystrokes. So as I was kind of learning, wow, I wonder if I could actually just go ahead and enter these keystrokes in for the repetitive work that I have to do without actually having to sit there and do the repetitive work, because it is something that could be automated. That's when I started looking into what different solutions there were, and at the time Python was just starting to kind of present itself as a automation solution for networking. I believe the Paramiko SSH package had just come out, and we've since moved on from that and developed more against that. When you start to work with Python, you'll notice it's very readable. So it's also being chosen as kind of like a nice entry-level language, whereas something like JavaScript or Java is going to have much stricter syntax and can be a little bit more advanced with its syntax. I would say that Python is definitely more easier to read as you go through it, and the syntax is way less strict, and Python will try and execute the code even if it comes across a syntax error. It's going to try and do its best to interpret what it is that you're trying to do and execute that code. Then we have the Python interpreter, which we can launch a instance of Python just by entering in the Python command, and then we are in a interactive Python shell where we can use it to practice, research, and just test out different things that we want to use or leverage Python to do. It comes with a package library. So what the package library is it's an online library, and it allows you to download pre-built code that people have already built for you. So I don't need to code into Python, for instance, the key exchange that happens with an SSH connection. Somebody's already done that. That's called the Paramiko library. I also don't need to code in the ability for Python to run commands on network devices. The netmiko package already exists, which also includes the paramiko package. So as you can see, it really evolves and develops as time goes on, and people continue to develop more and more of these packages. And then it is an object-oriented programming language, and we'll be covering that more in the next modules. We get into the definition of object-oriented programming, and then we'll also be actually creating different objects using these theories called classes and methods, and then different functions. All right, so this is the Zen of Python. Just kind of I couldn't really call it a marketing scheme, but it is built into Python, and it's just kind of a phrase or something that is used. So I'm just going to kind of cover the Zen of Python real quick, and there is an Easter egg built into Python that allows you to pull up the Zen of Python at any time. I will be giving that to you in, I believe it's the next lecture, where we cover modules, and we'll be able to import this and check out the Zen of Python. But it says, beautiful is better than ugly. So how you write your code is, the efficiency of the code is always up for debate, but it is important that you keep it nicely formatted and pretty to read. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. Special cases aren't special enough to break the rules. Although practically beats purity, errors should never pass silently unless explicitly silenced. In the face of ambiguity, refuse the temptation to guess. There should be one, and preferably only one, obvious way to do it, although that may not be the obvious at first unless you're Dutch. Now is better than never, although never is often better than right now. If the implementation is hard to explain, it's a bad idea. If the implementation is easy to explain, it may be a good idea. Namespaces are one honking great idea. Let's do more of those. All right, so the Python interpreter. So what this is, it's an interactive Python environment. So it's kind of similar to the command line in that you are in an interactive Python shell, and it allows you to really experiment with Python, learn more about the language, the syntax, and take a look at your errors, read what it is that the interpreter in the shell is telling you, and work through those areas, which allows you to build your Python skills and makes you more of an advanced programmer. It is interactive, so you can give it variables, declare them on the spot. You've got a couple of other ways in which you could run Python code. One of them is with the Python command passing in the name of your script, and then you can also add a shebang to the top of your code, and then change the permissions on the program itself to be executable. I like to refer to it as a playground. You will commonly hear it referred to as a playground, and just really what a playground is a place for you to go and experiment with different technologies. But you do get to run your code directly in the terminal, which is very useful for debugging, because if you have some code that's failing, you can see the error messages displayed to you in the interpreter. And your shebang, if you're not familiar with what a shebang is, that's the pound and the exclamation point and then a path to your Python. So with the Python interpreter, we enter it by just throwing in the Python command. So the command is just Python 3. You'll learn that once we actually start to create virtual environments, that it accepts just the regular Python code, because there is a difference between Python 2.7 which has since been depreciated. It doesn't even come installed with Linux natively anymore. Now it comes directly out with Python 3. So if you notice that your command Python sometimes works, there it is important to actually look at the interpreter and see which version of Python that you're running, because you can still install Python 2.7, but it's really dead. It's one of the few technologies that I've ever learned about as I started to pick up and initially started working with Python. 2.7 was still very much alive and available, and everyone was saying how it's going away, but then there was some debate about that. But no, this is one that they did follow through with, and it has since been depreciated, and Python 3 has been the standard since. But they tried to keep the commands very simple, whereas your old Python command, now you're just adding a 3 onto it. But as virtual environments came out, they do allow you just to enter in the Python command, so we'll notice that when we start to create some of our virtual environments. All right, so a Python package. We have this tool called pip, and what pip stands for is Python installs packages. So what is a Python package? It is just pre-built code that is designed to do something specific in Python. So there's packages for networking, there's packages for interacting with APIs. Whatever it is that you're trying to do, that's really what you should be asking yourself, is what is it that you want to do, and that will help you go search for a package that you can use to help better make your coding more efficient, so that you don't have to code in a lot of advanced interactions between the system and the firmware. So we're going to be learning about the pip command and how we can search for different packages, how we can install and remove packages, how we can see what packages are installed using the pip freeze command. And then when we actually get to working in virtual environments, you'll learn how to use the pip freeze command to make this thing called a requirements.txt file, but I'll be covering that in the next slide where we go over virtual environments. Here I've got a couple popular packages that are very specific to networking. The first one is request. That one is not so much of a networking package, but a package for working with APIs. So we would install that via pip, and then you can verify it's been installed with the pip freeze command. NetMiko, which is the package used for interacting with devices via SSH. I apologize, my dog is wants to play right now. My NetMiko package, which is the Python package for interacting with network devices via SSH. And then we have Napalm, which is used for network automation. And how you actually use those packages is we have to use this thing called the import statement, where we import the module either into the interpreter or into our Python code. And that is just simply import and then the name of the package, although we'll be looking at some more advanced use cases for the import statement when we cover modules later in the course. All right, virtual environments. So they've become quite popular, and what virtual environments are is if you install Python on your native operating system, you now have a native version of Python running. So what virtual environments allow you to do is create a bare bones installation of Python with really no packages available off the bat, but then you can just install only the packages that are required in order for you to complete your project. So we create our virtual environment, and then what we do is we source the terminal to look at that virtual environment instead of looking at the native installation of Python that's running on our OS, and we will be covering that in the lab, and I'll also be covering it in the demonstration. So your native version is what is actually installed on the core operating system, and then your virtual environment creates just this bare bones installation, and we point the terminal to that Python, to that environment, and we'll even have a little indication in our terminal indicating that we are indeed in a virtual environment. As we add packages, we can create this thing called the requirements.txt file, and that should travel with the project itself. All that is the output of the pip freeze command, and that lets anybody know that wants to work on your project or recreate it, they can then just download the the code repository from, let's say, GitHub, and included in that repository is going to be the requirements.txt file, and then they can just install all the necessary Python packages they need in their own virtual environment, and they have the project up and running. So this makes the projects very portable, and that's why you covered GitHub, was because by using these virtual environments and the requirements.txt file, you can keep your code in that repository, and then people from all around the world can just download the repository and work and recreate the projects together. I added in here the gitignore file because when you make a virtual environment, as I've already stated, you're going to be creating a full bare bones installation of Python. So all the binaries and libraries that are included with Python, you do not want that to go into your core, into your code repository. It's useless up there, it takes up a lot of space, and there's just no reason to have that up there. The whole point of a virtual environment is so that it's lightweight, and if you include the virtual environment with the repository, then it's not lightweight anymore. It actually becomes quite heavy because now you've got to have the virtual environment traverse with it. So what you can do is just add the name of your virtual environment to the gitignore file so that it is not tracked with Git. All right, so here we're starting to now get into some Python theory. So we've got this thing called variables. You may be familiar with this already. You should have covered a little bit of scripting in your Linux Plus course, or perhaps you've had a programming course in the past. But all a variable is a logical something in your code that you give it a name, and then you define a value with it. So there I have, it is a value mapped to another value. So you name it, the name of the variable, and then you define it with the equal symbol. And then you've got different types of variables that you can actually define. When you are writing code, it is very important that you know that the syntax is extremely strict when it comes to coding. So the slightest quote, comma, equal sign, the one thing out of place, indentation, spacing, all that stuff needs to be taken into account, otherwise your code will not work. So the same way, it interprets each variable differently, whether it be a string, which is just going to be a string of text that should be enclosed in some quotes. It could be an integer, which is just simply a number, but then Python is actually going to interpret that variable as an integer, and we have a couple rules when it comes to adding variables together or working with our data, in that numbers can't be combined with strings, and we'll look at how to remediate some of those errors we may see where we may have to swap the variable between being a string one time and being a number the other. Then you have a float, which is just simply a decimal number, pi 3.14, but it's something with a decimal point in it. It's just a number with a decimal point. Not very commonly used as far as infrastructure scripting. If anything, I do stand by what I say, in that we are mostly going to be working with strings and integers. Biggest use case for integers, though, is for just some basic counting. So to count how many devices that you're connecting to, how many times something that failed. We don't do a whole lot of advanced math or math in general when it comes to infrastructure scripting and coding. And then you have Boolean objects, which all that is something is true or false. It's very binary. It's 1 or 0. It is either true or it is either false. There is no in between. All right, then we're moving on to lists. And what lists are, I don't like the way I worded it actually right here. Oh, excuse me. I don't like the way I worded it right here because I shouldn't have put the word object right there. A lot of the terminology used in scripting and coding can be very similar, and I feel like I made a mistake right here by using the word objects, because when we get into object-oriented programming, that's where you can see it could get a little confusing. So all a list is see where that's where it's really difficult to kind of get the right word for it. I would say it's a list of elements. That elements could be variables. They could be variables that are directly declared in the list, and we will look at what I mean by being directly declared in the list, vice the list being full of variables that have been declared somewhere else in the code. In order to define a list, we have to give it a name and then an equal symbol, but it is defined with square brackets. That's how we know that we're actually looking at a list. And then all of your elements are separated by commas. They can be dynamic, so you can add to a list, you can remove from a list, you can search through a list, you can perform an operation against each item in a list. There's tons of things that we can do. We can have a list that is all strings, all variables, a combination. We could have a list of dictionaries, lists of other lists. You can just keep going with it. But it does go by this concept of indexing, and each element is at an index place. So here you can see I've got object 1, and these are not in quotes, so this is telling me that these are declared somewhere else in the code. But I've got object 1, and then so enclosed in square brackets, here's object 1, separated by a comma. You'll notice that there's no quotes, which means this is not being created in the list. But what the index value is this would be space 0, 1, 2, 3, and then it can even go back around, 4, 5, 6, 7, and it can just keep going, 8, 9, 10, 11. But it's just this first element is at index 0. So if I called index 0, it would return this element. Same if I put in a negative number, 0, -1, -2, -3, -4, and so on and so forth, -5, -6, -7, -8. And that's how we reference items in a list, is by their index value. The index starts with 0. All right, then we get into dictionaries. And what dictionaries are key value pairs. So unlike lists where we're pulling from the index value, in dictionaries we pull via using the key. So it's key value pairs, and then you can see in the example down here that they are defined using these curly brackets. Here we have the key, which is included in quotations, a colon, and then the value, and then we have a comma separating the next item in the dictionary. And again, we can have a list of dictionaries. We can have a dictionary where the values are also lists. The combinations are really endless. And same with lists, they are dynamic, so you can add or remove items to a dictionary. You can update dictionaries. You can put tuples into dictionaries. One thing about dictionaries is that this syntax that it uses is also very similar to JSON, which we're going to cover later on in the course, but that's something that is very commonly used when making API calls. So here's our first key value pair, separated by a comma. Our second key value pair, separated by a comma. And then our third key value pair, and you'll notice it does not have a comma at the end, which indicates that this is the end of the dictionary. For the values, they can be variables that are declared directly in the dictionary. Because these don't have quotes around it, this is telling me that this is more than likely a variable that was declared somewhere else in the script, and it is referencing the value of that variable. If these were included in quotes, that would be telling me that this was a string. But also, they could be lists, they could be tuples, I could have dictionaries nested inside of dictionaries, possibilities, endless. All right, tuples, they are very similar to lists, but tuples, the biggest difference is, besides that they are defined with parentheses, vice the square brackets that lists are defined as, they cannot change. Once you define a tuple, those values are stuck. They cannot be changed. They are immutable. They are not dynamic. So that is where they're used less often, except for like if you actually can't have something being changed. So down here you can see I have the example where I've got the tuple declared using parentheses. And then I've got the first element in the tuple, the second one, the third, and then they also use index values as well. You can declare the value directly in the tuple just like you would a list, or it can reference a variable that is somewhere else, and that variable can be dynamic, but the tuple itself is not. So the tuple, if it's referencing variable object 1, it will always be referencing object 1. If the value of object 1 changes somewhere else, that you can do, but the tuple itself cannot change. Okay, functions. We're going to actually be building our own functions next week, so we'll be getting into a much more deep dive into functions, but all functions is a pre-built block of code that we are going to call and we are going to use. There are some functions that are built in and come directly with Python. The most common one that we're going to see and use is the print function, so that we can print things to the terminal. You can always tell a function because it also has these parentheses, and then you can pass information into the function if it even accepts information. Those are called arguments. You would put those inside of the parentheses, and that's how you pass information into a function. And again, this is where the Python interpreter is a great point to start learning about functions and kind of using the print function to play with it, see how it works. We have the type function, which is another very useful function, and that tells us how Python is interpreting either a piece of data or a data set. And then we can pass in, let's say, a variable into the type function, and it'll tell us if it's a string, if it's an integer, a dictionary, a list, however it is that Python is interpreting that value or that element. We've got the input function, and this is how we accept input from the user. I'm going to stress very quickly, though, we do not use the input function to accept passwords. When you use the input function, you will notice that what the user then types is displayed on the screen. So that does not protect the user from shoulder surfers or screen crabs, which can then see the user's password. Instead, we would use the getPass function for passwords, and we will be covering that in this course. But it is also important to note that of the input function, because there's tons of ways in which you would need to accept input from a user, or reasons that you would need to accept input from a user, and it's a really good tool to continue to learn about loops and conditional matching is using the input function. We can create our own custom functions. We'll be learning how to do that next week, where we build classes and functions and different methods. When we download a package, we are also downloading the functions included in that package. So as we start to learn about different theories of Python, classes, methods, functions, you will see that we have to not only do we have to install the package, but then we also have to import the module, which could also include importing the different functions included in that package. All right, so here we have if, else, if, and else statements. And what that does is if it checks to see if a condition is matched. So how you write these are going to be, if something happens, then do this. I believe that's how it's worded in Java. It's if, then, else statements. In Python, it's if, else if and else. So you could do, you know, like I believe in the lab I reference like a car. So if you're coming up to like a stoplight, you know, if light is green, keep going. Else, if light is yellow, start to slow down. Else, light is red, then you stop. So it's just kind of checking to make sure those conditions are matched. You've got different operators that you can use, and your book, the DevNet Associate book actually outlines what those operators are. So you've got equals to, less than, greater than or equal to, less than or equal to, not equal to. And you can also use different combinations of those, as well as skip the operators altogether, and you can actually do combinations and combine things with the words and. So if something equals something else and this equals that, so let's say like if light equals green and no cars in front of you, then press gas. Else if light equals yellow and no cars, then and cars braking, slow down. Else light equals red and cars in front of you, then hit brake. There's a very specific syntax to these. This is where I really recommend that you take a look at a code editor of your choice. Again, Notepad++ is free, and that's available. You just need to let it know that you're writing in Python. Atom is what I choose to use, but I did start with Notepad++ as I started to continue to develop, and I needed different packages and tools for my development environment. That's when I moved on to Atom, and I'll try and post a quick little description about Notepad++, Atom, and a development environment on my YouTube channel, so you can have kind of something to reference there. But what I mean by the development environment is I've already stated that, you know, the syntax for coding is very specific and it has to be exact or the code will not work. What these development environments do is it picks up that like you're writing an if statement and make sure that you write it correctly or it'll point your error out. And for instance, indentations are very important in loops so that when you hit an enter after you write your initial if statement, it will then indent for you. So it kind of helps you to write your code and practices a lot of the structure that you would need without you having to really think about it. But indentation really matters. Else is not required, neither is else if. Those are not required necessarily, so it could be if this equals that, then do this, or if this condition meets, do this, but you don't need the entire statements in there if you do not want to. You could also use the if something, and that's basically, it's like an empty statement, so if dog, and then it just enters the loop for you, but we'll be, that's a little more advanced that we're going to be covering. I don't think we will actually need to cover that in this book, in this course, but if you did get the Automate the Boring Stuff with Python book, and as you continue to practice and research these technologies, you'll notice that you can do a lot more with them. Okay, a for loop. A for loop is typically more used to actually to loop through items in a list. That's the most common use case for a for loop. And I even put the syntax up here a little bit so that you can see it. And so that's what you see here in italics. So it's for item in list, and then you can see it stops with some colons, and the next items here would need to be indented. And what that would do is loop through each item in the list and perform the action that you code in the for loop against each of those items. So there's a little example over here on the left. So it says for X in rock bands, which rock bands is an empty list that we can see up there. And then they add a couple of different options to the list. They add Roxette, Guns N' Roses, and U2. And then they say for X, so they declare the variable X in rock bands, and then they put the colon with an indentation, and it says print the variable X. So it would then just print each one of these variables to the screen. So that's just a nice little simple example of a for loop right there, but we'll be going over some of those in the demo. You can also nest loop, so you can do for each item in your list and then nest it with like an if statement so that you're performing that if statement for each item in the list. You define the variable for use within the loop, and what I mean by that is, although we are referencing the rock band's list right here, and we can see it up there, we're declaring X, and X is actually what we are calling within the loop to perform the action against. So we're passing a list into the for loop. And the last one we have is while loops, and that is while a condition exists, do something. In your lab, I do a simple counting statement for while loops because that's one of the easy ones to really demonstrate what while loops do. You do have a very high chance of the possibility that you create an infinite loop when you're creating your while loops. You could also ask for user input to exit a while loop. There's a couple of different statements that you can use, such as break, which will get you out of the loop. You can also use a Control-C to exit the loop. But it's just important that you kind of be careful and be aware that you could create an infinite loop when you're creating while loops. So, for example, you could also do while true and then use a break statement to exit the loop, and that just means like the loop is going to continue to run until we get some sort of break in there. Can be used to move items from one list to another. You can also remove all instances or specific values from a list or a dictionary until that you've got everything out of there that it is that you're trying to do. But realistically, when we're talking about these loops, you need to think of them as just tools to use in your code to perform specific actions. And this is where I really encourage you to look at different examples that you may find online in your book. When I started coding, I'm self-taught for the most part. So I've got a bunch of different books that I used, as well as a bunch of different resources on the internet. And I would also speak with people who had some experience in Python and coding to help me work through some of my errors. But eventually, that's where I stress that learning a programming languages is a journey. It is not something short. It's definitely not something I'm going to teach you in a couple weeks. So you've got to remain persistent with it and keep at it. Maybe you put it down for a little while and pick it up later. I'm going to be introducing you to Cisco DevNet here in the next couple weeks and kind of going over that and how that can be useful. But that is something that I'm noticing with a lot of people who are on top of this new way of managing enterprise networks, network programmability, and automation, that they all say the same thing because not only do you have to learn networking, now you also have to learn a programming language. So what I do, and that's kind of what I'm noticing other people do as well, is they'll swap back and forth between the two, but the key is just to remain persistent and not give up. Your skills will eventually continue to grow to the point where you find yourself actually being able to use it on the job. Start asking yourself again, can I automate this if you are performing repetitive tasks? Okay, so here I am on the SDN VM. I am SSH'd into it. It is the same VM I have provided to you. So the first thing I want to cover is the difference between Python and Python 3. So Python is the command that you would run to enter into Python 2.7, which has since been depreciated. So if I run the command Python and I try and check the version, you can see it's telling me that it's not found. But I can still install it if I wanted to, and if you're using an older version of Linux, or perhaps you've got an old version of Python 2.7 already installed, I just want you to be aware of that, as you could potentially see it. So if I run the command Python 3 and check the version, you can see it's telling me that I've got 3.8.5 installed. All right, so now I know what version of Python I'm running, and you also notice if I enter just Python, it does not do anything for me, and that's telling me I'm trying to enter a Python interpreter. But if I enter Python 3, You can see now I'm in the Python interpreter, and it tells me right there that I am running version 3.8.5. So in the interpreter, it will also tell me which version of Python that I'm running. And then it also says that, I can enter help, copyright, credits, or license for more information. To exit out of the interpreter, I simply run the quit function, and it drops me out of the Python interpreter. So we are good there. Now, as I've stated already, the SDN VM came with all the tools that you need in order to complete your lab. So Python 3 Venv is already installed for you. But if you were starting it up from a new machine, you would always want to update your packages first. So I'm going to do a sudo apt-get update. And it's going to prompt me for my password. It's updating all the packages. And now my packages are up to date. Okay, good. So I would just do a sudo apt-get install. I believe it's a Python 3 Venv, but it's probably going to tell me that it's already installed. Yep, and there you can see Python 3 Venv is already the newest version running. So here I can already tell that I have Python 3 Venv already installed. So in order to create a virtual environment, the command is going to be Python 3, and then we use the option M. I always remember M because to me that's kind of saying like module or menu item or something like that. That's just what I've always used. So I'm saying like the Python 3 module. I want to run the Venv module, which is virtual environment. That's what that stands for. And then I can name my virtual environment anything I want. So for the first one, I'll do Venv, and I'll just do a lowercase to make it simple, FSCJ. And before I enter that command, though, let's go ahead and see where I'm at. So here you can see I'm just in the root directory of the SDN student user. So there is nothing else here. I will go ahead and make a directory, and I'll call it a mod2 demo. Make sure my directory showed up, and then I will go ahead and get into the mod2 directory. Make sure there's nothing in it. All right, cool. So now let's go ahead and create the virtual environment. So I'm going to do a Python 3 M, and then I'm going to invoke the virtual environment module, and I'll call it FSCJ. And you'll notice it takes a second, but the command ran successfully. And now if I do a list, you can see I've got a directory called FSCJ. So if I look inside that FSCJ directory, you can see it added some binaries, a few different libraries, a config, and then a shared directory. Now I'm going to look in that binary one really quick just to show you what's in there, because this is how we're going to actually activate our Python 3 virtual environment. You'll notice there's a couple different scripts in here, including just activate, which doesn't have an extension like a bash extension, but I do have activate ps1, which is a PowerShell extension. You can also do Python virtual environments on a Windows machine, because like I said, virtual environments are for Python. They're not necessarily for the operating system, but the difference would be I would tell you to research that a little bit, but they would have more scripts in there that are kind of native to Windows in order to activate your virtual environment. Okay, so where was we? Got FSCJ right there. Cool. And with that, I'm going to go ahead and clear this out. So to demonstrate what the difference is in our virtual environments really quick, I'm going to go ahead and activate that. So to activate in Linux, we have to source it. So I'm going to do a source FSCJ bin, and you can see I'm using my tab key quite a bit to help complete the paths, because if I do a tab, even just F, there's no option, so it automatically completes the path for me. So I do source FSCJ bin and then activate. And when I do that, you'll notice that on the left there, it is now letting me know that I am in the FSCJ virtual environment, that I have that virtual environment activated. And you can see that on the command on the left on my little command prompt there. Okay, cool. So now that I've activated it, let's do a list, and you can see I can still see FSCJ, but this is where I would actually start to work with my Python virtual environment. And we'll notice that I can now enter just the Python command, because underneath our fscj bin, you'll see it allows us to enter just pip or pip3, Python or Python 3, and we'll be using pip to install some packages here in just a minute. But this one's a bare bones installation, so if I type the command Python and then version, we can see now that the command is successful, even though I didn't have to add the 3, and it still tells me I'm running version 3.8.5. So if I run the command Python and hit enter, I am now in the Python 3 interpreter. So I'm going to go ahead and quit out of the interpreter, clear that, and now I'll deactivate the virtual environment with the deactivate command, and you see, okay, deactivate, and then went ahead and gave me my options. I had just hit deactivate, and you can see now I'm out of that virtual environment, and if I try and invoke the Python interpreter without the 3, you can see it now fails. So those are just some real easy ways you can quickly tell if you're in or not in your virtual environment. And now let's go ahead and talk about some pip and how to use it to install different Python packages. So I am not in my virtual environment right now, so I'm going to issue the command pip, and I'll check the version, and pip stands for Python installs packages, so it's telling me the command is not found, but since I'm not in a virtual environment, chances are it's just missing the 3, so I'm doing pip3 version, and you can see that I do have pip3 installed for Python 3. To see all the packages that I have installed, the command is going to be pip3 and then freeze. And you can see natively, out of the box, we get quite a few Python packages that come with Python 3 just from a bare bones installation. Or if I were to install any packages right now using the pip3 command, those would be installed in my native instance of Python. So let's go ahead and take a look at that virtual environment again, and what I'm going to do now is I'm going to actually remove that virtual environment. So I'll do a sudo remove fscj, and I'm going to do it recursively and force it. So now we can see my virtual environment is completely gone. I can do also a list all, and I have nothing in here. So now I'll just create a new virtual environment. I will call it mod2, and then we can see my virtual environment came up. So I will source for mod2 bin, and I will activate my virtual environment. So we can see the mod2 virtual environment is now active. So let me run that pip version command again, and you can see that it now works. It lets me know that it is running for Python 3.8, and I have pip installed, but now you can see I don't have to add the 3 to the end if I don't want to. I can still add it if you would like to, if that's the way you want to work. Nothing wrong with that. It still works just fine, but inside of a virtual environment, you do have that option to just enter pip or Python. So let's see what packages I have in my virtual environment, in my virtual instance of Python. So I'll do a pip freeze, and you can see I've got nothing. That's what I mean by this is a bare bones installation of Python. So I'm going to go ahead and do a pip search for the request package. And oh, I ran into an error there. Let's try that. Let's see if it allows me to do a pip3 search for requests. All right, so these are Python errors that I'm getting, but I think that should be local to this might be local to just the virtual environment. So I'm going to go ahead and deactivate it real quick just to see. And I do want to point out that as I go through these demos, I actually do believe it's important that I make these mistakes, and you can see them. I would not expect these to be perfect in any way. It's something that I've honestly just picked up from some YouTubers that I like to watch, and they kind of go through the same thing. Like, look, I'm going to be making mistakes because I do think it's important to understand that you're going to make mistakes and how to work through them. So as you can kind of see, I'm now working through a methodology where I just deactivated my virtual environment to see if I'm running the command correctly. So now I'll do a search for request. And I'm still getting the error. Okay, so I can do a pip3. Maybe I am entering the command wrong. Let's see what we got up here. No, it says search right there, but perhaps I'm missing pip3 command search, and then search py for packages. Manage global and mobile configs. Okay. Interesting. This virtual environment is running on a remote host, so could be something to do in there. I may have to upgrade pip as well. I just upgraded this virtual machine, so let me go ahead and just do a pip3, and I will install requests. Requirement already satisfied. Okay, so I'm just going to go ahead and ignore that, and I will cover that later as I continue to troubleshoot, because I do want to focus on the core stuff that we're learning. Like I said, I upgraded this VM just yesterday, so I'm expecting some errors that I haven't ran into in the past, because the original SDN VM, this is no longer that one. I wanted to upgrade it and run into any problems, so it's something that I got to note as I work through and upgrade that VM, that now I got to see what's going on with the pip search feature. But I'm going to go ahead and get back into our virtual environment. So it's going to be bin, activate, and here I will go ahead and do a pip freeze again, just so we can see that we have nothing installed. Okay, so I'll do a pip install requests. And now you can see it installed the package request. So if I do a pip freeze, you can see I now only have, I've got requests, but then it also installed any packages necessary in order for a request to work. So it came with a couple child packages, one of them being a certificate, so that it can handle the site certificates, because request is used to interact with APIs and websites. And then URL lib3, so that's going to help us with URLs. I'm not quite sure what the other two packages are, but it's not important, to be completely honest, because I'm worried about the requests, learning about the requests, not the child packages that come along with it. But as I create and add packages, this is where I now want to also, that I'm working in my virtual environment, I want to start creating that requirements file. So I'm going to do a pip freeze and pipe that out to a requirements.txt. I can see the requirements.txt, so let me take a look at that. Okay, good. So now I can see that request has successfully been installed, and I've added that to my requirements file. I'll do one more installation really quick, just so we can see that as you continue to install packages, you need to continuously update your requirements file. So I'll do a pip install netmiko, which is going to be the package that we use to SSH and interact with network devices. There's a lot more that goes along with netmiko, because it was built off of a lot of things such as paramiko, cryptography, SSH, and serial connections, different things like that. So now if I look at pip freeze, we can see I've got much more packages that are included. So I'm just going to go ahead and update that requirements file with the pip freeze, and I'm going to overwrite what is already currently there. You can see there's the requirements file, and if I cat out the requirements file, we can see that it has been updated. I did not append, I overwrote it because my original packages are still in there. Now I'm just going to go ahead and deactivate this really quick. And here you can see mod 2 is still there, and so is my requirements.txt. But I'm back to my native installation. Okay, so one thing I'm also going to show you as demonstrate really quick here is persistence across virtual environments. So if I do a source mod2 bin activate my virtual environment again, issue the pip freeze, we can see that all the packages that I originally installed are still indeed there. So it does maintain that as it goes, but you still do not want to upload that mod2, which is the virtual environment directory and all of its contents. You don't want to upload that to a code repository because there's a lot of libraries and stuff that goes in there. So to show you, you know, how dynamic and lightweight we can keep these projects, I'm going to do a touch, and I'm just going to make a example. Actually, I will do echo print hello world, and then I'll pipe that out to hello.py list, and you can see I now have hello.py right there. So if I cat out hello.py, we can see it just says print hello world. So I'm going to run Python hello.py, and there you can see I get a nice little hello world. I'm still in my virtual environment, so now you can see I've got a script that prints to this terminal hello world, my mod2 virtual environment, as well as my requirements.txt file. So let's go ahead and deactivate my virtual environment, and I'm now out of my virtual environment. So if I try and run Python hello world, it's not going to work because I don't have Python 2 installed, so I've got to run Python 3 hello.py, and it works just fine. So now I'm going to go ahead and delete my virtual environment. So I'm going to sudo remove, and then I will do mod2 and recursively force it to be removed. And now I can see I still have my hello.py and my requirements.txt file, but my virtual environment is gone. So let's go ahead and make another virtual environment. So Python 3 module vend, and I will do fscj as my virtual environment. So I'll source fscj bin activate. Now I'm in a new virtual environment. So if I run pip freeze again, you can see I don't have anything installed. But what I do have is my requirements.txt file with everything that I need if this was a more complicated script, everything that I would need in order to run this. So now, because I have an up-to-date requirements.txt file, what I can do is do a pip install and then an R option which says I'm passing you a requirements.txt file, and it will install everything in the requirements.txt file for us. All right, cool. So now if I run the pip freeze command again, you can see I now have all of my Python packages back. All right, so I think that's about it as far as pip and Python. So let's go ahead and actually start to work in the interpreter. And actually, I'm going to leave our virtual environment activated. Okay. So I'm going to enter into the Python interpreter just by running the Python command because I am still in our virtual environment. And what I'm going to do first is just declare a couple of variables. So I'm going to go ahead and declare these three variables, net device 1, 2, and 3, all named router 1, router 2, and router 3. And I'm going to call that print function, which is right there. And you can see I passed it nothing, so it printed nothing. But now if I pass in the name of the variable, which is going to be net device 1, and you'll notice that I'm not using any quotes or anything like that. I'm just passing in simply the name of the variable, and it prints out the value of that variable. So really quick here, just so we can kind of cover that. So here, I apologize. Let me get the right tool up. All right, so right here is the name of the variable. So these are the names of the variables that we have defined. And then I do a space equals, which declares it, and since I did these single quotes right here, what that is saying is that this is going to be a string. And then I just passed in the name of the variable into our print function. Okay. So if I wanted to figure out, how Python is actually reading my variable, I can do the type function. So if I do type, you can see it says it's giving me an error. Type takes 1 or 3 arguments. I did not pass in a single argument. So I'm going to go ahead and pass in one of our variables really quick. So I'll pass in a netdevice2. And you can see it gives me a class of str, which means it is a string. So there is a really quick way just to go ahead and tell you what kind of variable it is that you're working with. If I wanted to do an integer, I could do a number, and I'll just do number equals 100, no quotes. So I've declared that variable, and I'll say number2 equals 20, no quotes. So if I run type against number, you can see it gives me class integer. If I print number, it prints the value. And I can even do, let's say, sum or both numbers. So I'll declare another variable and say both numbers, and it's going to be equal to, and then Python understands it's a base calculator, so it can do regular calculating functions. So I'm going to do number1 plus number2, and that is going to be what the value of both numbers is them added together. So if I enter that, you can see it takes. If I run type again against both numbers, you can say it still says that it's an integer. So I'm going to go ahead and print both numbers, and there you can see it gives me 120, which is 100 plus 20. Now in the interpreter, I can also just say both numbers, hit enter, and it will give me the value. But that's an interpreter feature, is I can see the value of any one of my variables just by typing the variable in. That would not work in your regular code for the most part. All right, so now we're going to move on to list, but I'll just go ahead and keep that where it is. I really don't like how I don't have that clear option, like clear my scroll back, just because it makes it so that I'm working at the bottom of the screen, which I'm just not a fan of, but it is what it is. Going in and out would be kind of a pain. Oh, if I try to add 2 strings together, so let me do both variables equals, and then we will do, we'll try and add netdevice1 with our first variable number. You will see we get an error, and it says can only concatenate, I can never pronounce that, I'm sorry, string, not integers. So it says that basically it's saying I can't add a string and an integer together because I'm seeing one as a number and one as a string. But what I can do is I can do both variables equals to netdevice, because that is a string, and then I can do plus, and I'm just going to statically tell Python, you know what, treat this as a string. Treat the number variable as a string, and you can see that took, so let's see what the value of both variables is. You can see it's router 1 and then 100. That's also important when it comes to adding strings together is spacing. So you can see there was no space that was added right there. So I can overwrite variables as well. They are dynamic, so they can be overwritten at a later point in your code. So let's go ahead and just redefine that, as we discovered, oh, we wanted a space right there. So I would do plus, and then I would just add another quote with a space right there, plus, and then string number. Net device. Oh, I did net devices, which which is not the name. So there it's even saying, hey, you don't have that variable defined, which I did not. I removed the S, and as you can see, it then took. And so what we did there is we added a space in. So if we look at the value of both variables, now we can see it says router 1 space 100, which is, I guess, quote unquote, what we wanted. So as you can see, Python interpreter, great way to kind of get in here and just practice your Python skills. So back into the interpreter, but now if I do a print, and I'll do a net device 1, you can see it doesn't find net device 1 anymore. So I'll even try and print number. It doesn't have number anymore. So each session in your interpreter is local to just that session. So let me go ahead and add my variables back. And now I'm going to create a list. Of all 3 devices. So if I print devices, it prints out the entire list. And I want to point, sorry about that, I accidentally put the screen to sleep, so got to go back in here. But you can see here, let me get back in. Source FSCJ, bin activate. And add my list back. Okay, so what I was trying to point out here is we know that now that when I use these quotations right here, that it's going to be entered, that variable is going to be interpreted as a string. In my list, the name of the list is defined as devices, and then I've passed in each of my variables without quotations. That's where I can't stress enough how important it is that you focus and follow the syntax. I've placed a link in Canvas to Python syntax and good practices when it comes to writing your code. So again, I can print devices and it'll print out the entire list, but let's just say I wanted one item from that list. So we talked about the index values, and in order to call those index, you've got to use square brackets. And I already said that a list starts with 0. So now I'm saying I just want to print the element that is at index place 0, which is going to be net device 1. And then there you can see it prints out router 1 for me. Same goes for pretty much anything right here. Router 3, and you know what, I'll even add net device 4, and we'll do a switch 1, and net device 3, switch 2, and then let's just go ahead and how do I want to do these? So what I'm going to do now is I'm going to show you how to add an item to a list. And how we add it is you can either use the insert attribute, or the insert method, or you could use the append method. And the way that we work with those methods, there's tons to look up. They're all available online. And then as we continue on with the course, you'll be learning different ways that you can use things within Python to help you. But again, that's where it really just gets into building your skills. But I'm going to go ahead and append those two variables to our list. So I'm going to do devices.append, and that dot append is how I then call the append method. And then I'm going to go ahead and just pass in net device 4. And if I print devices, you can see it now added that device to my list. So I'll do devices.append again, and I'll add net device 5. Did I spell wrong? Oh, I overwrote net device 3 for my bad. Interesting. So the reason that I'm still seeing router 3, although this is where I always say it's very good to actually walk through some of these troubleshooting skills. So I want to point something out right here. I meant to hit 5 right here, but I overwrote the variable net device 3, which was, what was that, router 3 with switch 2. However, when I printed my list again, remember my list is still pointed to net device 3. However, when I declared that list, that variable's value was still router 3. So the list itself has not been overwritten yet. So you can see, although I printed it and it says router 3, I declared the list at the top of our code, which was up there. And at the time, that was at router 3. I've appended net device 5, but that doesn't mean that I've removed the reference for that or the value for that variable. So again, could not stress enough why it's important that you actually get in to this interpreter and play with Python. So I'll put net device 3, I'll correct that back to router 3, just so we don't get confused, and then I'll actually add my net device 5, which is what I meant, and we'll do switch 2, net device, and then let me just confirm that 3 is router 3, and then net device 5 is switch 2. Let me check out my list. All right, and so now we'll do devices.append, and I'll do net device 5. And if I look at my devices list again, you can see now I have switch 2 in there. I can also print out the devices list this way. All right, cool. All right, so it looks like we're good. So just kind of scrolling back up here again to take a look. When we declared the list, what we were adding was the name of the variable. But when we print it, we can see the values are actually printed. Now there's one other way we can do these. So I will create one more list, and I'll call it firewalls. Or, yeah, I'll do firewalls. And what you can do, it has to be square brackets, is you can declare items directly in your list as well. So I will do Palo 01, Palo 02, FortiGate 01, and FortiGate 02. And I'll close off my list. I'll just go ahead and call it directly. And so there's my firewalls list. And if I wanted to just print an item from its index value, let's do, I'll do a -1, -2. You can see it gives me FortiGate 01. And that is because -2, start 0, -1, -2. If I would have gone the other way, it would have been 0, 1, 2, 3, so on and so forth, depending on how big your list actually is. Okay. So, I'm going to get rid of that. There's tons of different methods that you can use with your list. So I've got another list here that's not network related, and I'm going to swap over to that one real quick because it's a pre-built one that I have, and it's just a bunch of different cars. So I'm going to go ahead and add those in here, and now you can see I've got all these different cars in here. But I can also do a cars sorted equals cars, and now I'm going to call the sort method, and all that is cars sort, and it's going to sort my list for me in alphabetical order. So there's my original list. And now if I look at cars sorted, it didn't print. Maybe it didn't take that. Did not take the method the way that I thought. Oh, nope. Okay, so I've got an empty list right now. Maybe if I just do sort. I'll bet you cars is now just sorted it. Yep, so it just sorted it for me. Okay, so it didn't allow me to add it to that variable the way it should have. No big deal. Really the point of this was that we could take a look at, like the sort method and just show you that there's a bunch of different methods that you can use. Another one, let's say we wanted to remove the last item from the list. We could also do cars.pop. And that's going to pop that last item from the list. So now if I print cars, you can see Mustang is no longer there because it popped out the last item from the list. So do cars.append, and I want to append Mustang back into it, but I want to append it as a string, not as its standalone variable. So I'll do cars again, and now you can see I have Mustang back. All right, cool. So another way we can do that, if you wanted to actually print the sorted value, it's already sorted again, but our devices isn't, so I can look at devices again. All right, actually that is automatically sorted, so that's not going to work either. Okay, no big deal. I was just going to show you that you could do a print, cars.sort. It still doesn't let you do that. That is interesting, because I should be able to do that. I'm going to have to take a look at that. All right, again, type. We can use our type function again, so let's take a look at what cars is, and you can see it's telling us right there that it is a list. A little bit more on adding values together, so I've got a couple more examples that we're going to walk through. So I'm going to declare this variable the year. And if I look at type, year, we can see that it's seeing it as an integer. And then I will do course, software-defined networking. And if I do a type against course, you can see it's seeing it as a string. Now I'm going to try and do a print statement to print a little message to the screen. It says the year is, and then it's just going to print the year, and the course is, and it's going to print the course. Correct? Wrong. What we forgot here is we forgot to add in the string, because again, we cannot add together integers and strings like that. So there it is. The year is 2021, and the course is software-defined networking. You can also go ahead and just put in, I'm swapping over to academics a little bit, so book cost, and I'm adding quotes for 35. So if I do a type on book cost 1, you can see it's reading it as a string. Book cost 2, reading it as a string. So if I do the total cost of the books added together, you can make a guess right now on what you think the output is going to be, remembering that now it is reading those as strings. In our earlier example, it was reading them as integers, and it added the numbers together. But if I do them as strings, and I take a look at the total cost, you can see it just adds the two numbers together as though they're strings. And this works for the actual print function as well. You can see it says the total cost of the book is $3,520, which is not correct. And this is an example of where you need to understand types and how they work together. Now, let's see if we can go ahead and declare those as integers, the same way we did strings. So we've got that. When we've created real cost, let's go ahead and look at real cost. And there we can see is 55, which looks a lot more realistic of what we wanted to see. So now if I go ahead and try and print this again with real cost, it is going to error out because it is a string, and then it's reading real cost as an integer. So I've got to swap it back over. So you can see coding or writing code, it's very meticulous. It's very specific. And now you can see the total cost of the books is $55. So moving on from lists to dictionaries, I've got a student dictionary that I'm going to go ahead and paste in right here. So I've got student 1 with a key of name. The value is the string John, separated by age, which a value is an integer, 36. Hometown is Jacksonville, and status is enrolled. So if I do a type against student 1, you can see it's a dictionary. If I wanted to just print out a single item from a dictionary, I'll go ahead and print the entire dictionary real quick. Student 1, and you can see it printed it like that. There's another function, but we'll get to pretty print when we get to pretty print. All right, so there it printed out the entire dictionary. And again, syntax is important in programming. It is key. So name of my dictionary, a curly bracket indicating the start of the dictionary, a curly bracket indicating the end. I'll underline, make that a little bit fatter. Everything in blue is a key. Key, 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 key. Value, 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 value. A comma is a separator. Another comma is a separator. Comma is a separator. And then no comma after the last key value pair, because that indicates this is the end of the dictionary. The separator between the, grab another one here, running out of colors. I'll do, I don't know, I'll just do like a purple. And that is for, oh, that didn't show up very well, is for the colon there that separates the key from the value. So that's a dictionary, it's a bunch of key value pairs. All right. So back to our code, if I wanted to just print a very specific value, what I would do is call the name of the dictionary, which is student 1, and this would print the entire dictionary just like we did up there. So student 1, and then we still need to use square brackets because we are calling a specific item from the data set. So if I just wanted, let's say, their hometown. I would print the dictionary, and then using those square brackets, I'm basically filtering out, I just want to see hometown, but you can see I call it by the key, not by an index value. All right, so I could do one more. Let's do student 1, and I just want to see, let's say, their age, which is 36. All right, cool. Now I do want to teach you a little bit about code readability, if you will. This is a good place really quick to kind of quit and clear my screen so I can start at the top, even though it's only temporary. I'm going to go ahead and paste in that student again. But we have another way that makes it just a little bit more legible when you're writing code. And as you can see right here, like if this dictionary kept going and got bigger and bigger and bigger, same goes with a list, it could eventually get quite long to where I wouldn't be able to see it unless I had an extremely wide screen, but even then it could continue to get longer to the point where I would have to scroll over to see it. So what we can do is, and this works actually very well in a text editor, or I mean a code editor, because it will kind of format this for you. If it'll pick up if you're trying to do that, because when you hit the enter key, you'll see what I mean. Oh, it didn't like one thing in there. What didn't it like? Oh, I might not like it in the interpreter, no. Or did I just miss? I think I just missed it. So let me try that again, because I can see that, yeah. So I think it just missed it. It's not taking that the way it should. Okay, I'm gonna have to enter it in manually. But what I can do is I can do student2 equals, and then I will start my dictionary. And now it's saying, what's up, what you want? So I'm just gonna do a tab, and I'll enter in my values right here. So I'll do Jane, tab, age. This is a copy-paste error, by the way, because I'm copying from my Mac and I'm pasting it to my iPad across devices, and for whatever reason, it's not picking up the end of the dictionary when I actually paste it in, so this isn't even a Python problem. But it did end of line while scanning, okay. It's going to want that as a string more than likely, just because of the way I'm entering it. Again, we wouldn't have this problem in a code editor. I'll probably add that code editing piece sooner rather than later. Oh no, it was because I missed a quote. See how meticulous it is? It noticed that I missed a quote, and it picked up on the comma when I hit enter and said, hey, you know, that's not right. You didn't finish it. So there we go. Now I fixed it. And I'll do a hometown. And for the hometown, I will do Miami. And I'm still not done because we still have a status of enrolled. And then I'll hit enter again. But you can see I still have not closed off my dictionary. So now I will close off my dictionary. And you can see this is just easier to read more than anything. I mean, that compared to that, but as far as readability is concerned, I can continue to add to this dictionary and it just looks more structured. So if I go to print student2, it prints the same way, all as one. So this is strictly for me, the human, is this whole little piece right here. That's all it's there for, is so that I can better read the code. And then I can even go ahead and I will call one item from this dictionary, and we'll do this, the status of the student. We can see that their status is enrolled. I'm gonna go ahead and add one more student here. But let me see if I'm gonna try the copy and paste one more time, and I just moved the curly bracket to see if this pastes a little bit better. Ah, there it was. All right, cool. Indentation's important. I had the curly bracket too far to the right. That's why I was erroring out. So there it took. And so, all right, so let's just print this student 3, Carol, 45 from Tampa, and she is interning right now. All right. So now I've got 3 dictionaries. trying to figure out the best route to go from here. Yeah, really quick, I'm going to go ahead and cover it. So I'll do print student 3, and then I'm going to call out name, and we can see the name is Carol, but shouldn't names be capitalized? So what I'm going to do is I'm going to call this title method, which should capitalize the first letter of the word. And let's see if that works and takes. All right, it did. So there you can even see I'm calling an item from our key value pair. Using the title method, it went ahead and capitalized Carol's name for us right there. All right, but if I print it again, just her name, it did not change the original value, just how it was displayed to us. So you can see there's tons of these methods in here that we can work with and make our code do whatever it is that we need to do. Now, I already covered that we can have a list of dictionaries, so I'm just going to go ahead and pop that in here real quick. So now I'm creating a list of all my student dictionaries. So I've got my list as students, student 1, 2, and 3. Enter. So if I do type on student 1, we can see it's giving me a class of dictionary. If I do a type on students, it's giving me a class of list. But now how do I pull student 2's first name? Well, we can then call the list at the index value of 1, because we're looking for student 1, and then we're going to add a second operator in there, and we will do it as name. And let's see if this is successful. It is. So there it prints out our student's name. So I can even come through here and pass in a 2, and then you can see Carol's name. I could even do a position variable, right? And I will set that equal to 20, you know, kind of like a random number. So I'll do a type position. You can see it's an integer, but if I do print students and then position, pass in my position variable, let's see if this works, and then I will filter out for the name. All right, I was hoping it would take that as an index, but it did not. It says it's out of range though, so let's go ahead and I'll just do index. Index equals 2. So let's try that again. Students index. I was not expecting the out of range error. Let's see if that works. There we go. All right, so it just didn't like 20. It was saying that's way too high for the amount of items that we have in here. But there you can see I still used a variable to pass that in for our index value. The variable's name is index, and it's got a value of 2, which is an integer. So therefore, Python was able to read it without any issues, and it noticed, hey, you know, you're looking for position 2, and you're trying to pull their name. I can even do throw those into methods as well. And I didn't take that copy. So here I'm using the upper method, which should print out the student at index position 1's hometown all in uppercase. So let's see that. All right, cool. So it's got Miami right there. Lots of methods, we can continue to go. If we wanted to add items to our dictionaries, we could do that as well. So I will just go ahead and do student 1 really quick. So we can see name, John, age 36, but let's say I want to add the last name. So I would do student 1, and then the key that I want, so I'll do last, and equals, and his last name is going to be Doe. So now if I print student 1, you can see at the end over here, it added in a new key for a last name of Doe. if I print students, and then he would be at index 0, last, let's see if that works. It does. All right, cool. Because it's referencing this dictionary, which we just updated. Works a little bit different than the list referencing variables, because it's referencing the dictionary, which is a little more dynamic. But if I try to do a student 1, key error last, which is telling me that that key does not exist. So I will go ahead and add in student 2, last, equal to, and I kept, I'll do Ray. Whoops. So print student 2. You can see last is Ray. And now if I go back up to that print for that position at 1, I believe that, yep, all right, cool. And again, you know, I could do the title method and capitalize her last name. All right. We can even add a list into our dictionary if we wanted to. So what I'm going to do now is add in onto student 3 all the courses that they are taking. So student 3, I'm adding in the key courses, and then I'm adding the list of software-defined networking, Wireshark, and Capstone. So now if I print student 3, we can see that it added courses, the key courses with a value of a list. So you can, as you can see, you know, these are all very dynamic and they can keep going and going. So now if I also wanted to do print, I'll just go ahead and copy this one from here. Print student 2 courses. We can see that the courses come up because it updated the student dictionary in our list, even though I was calling the student from the list. Lot to take in, I understand that, but that's where I encourage you to continue to practice. So now I'm going to add another dictionary, and it is going to be a dictionary within dictionaries. So inception of dictionaries. Let's see if it'll let me just go ahead and paste this whole thing. And it looks like it's taken. So here I have a dictionary of Harry Potter characters, and the keys are their name, and then the value is their information. So I'll go ahead and enter that. So even if I still do a type on Potter characters, still says it's a dictionary, so I will print Potter characters, and I now have to ask for a key because this is a dictionary, so I will say I want to print Harry. And then there you can see all of Harry's information. If I wanted to continue on there, I could say, you know, I could do first. And there it prints his name. Again, we can do title, so it capitalizes it. Here I decided to add a Boolean value just so you could see it though. So I have is mudblood as my value. So I've got it set to false. So I'll do a print Harry, and then I'll remove the title. I do is mudblood. And then there you can see it's telling me false. All right. I've got a couple more here. Let me see. That looks like, it looks more like redundant information, so I think we'll be okay. You know what, I'll go ahead and do one more. So I've just got the same thing in the less formatted version, so you can see how here everything looks nice and pretty. It's formatted. I would say this is fairly easy to read and to understand. This next one is showing what it would look like if we didn't format it and just kind of put everything on one line. It does not look very pretty. So although that took, as you can see, it's basically the same thing, only it's Star Wars characters. So I will print star characters. But even looking at it right now, you can see it's really hard to pull things out. But I can see Yoda in there. So I'll pull out Yoda. And then there you can see all of his information. So that really just emphasizes why it can be better to kind of format things this way. All right. So go ahead and we will start moving on to loops. So I'm going to go ahead and quit and clear my screen. Okay, so let's go ahead and work a little bit with loops. So I'm going to go back into our Python interpreter here, and I'll start with creating the cars list that I created earlier. So it's just a couple of different cars, and I'm declaring all of them directly in the list itself. So I'm going to do print cars 2 just to verify it's pulling everything. You can see there it's pulling number 2, and that's a Jetta. And now I'm going to create another variable, and I'm going to say desired car equals, and then I'll do a Bronco because I want to get one of the new Broncos. All right, so I can see that took, so I'm not even going to print it. But now to do a for loop. As I stated, a for loop is basically to go through each item in the list and do something to each item. So I will say for, and then I need to declare a variable that is going to be used within the loop itself. So for car, that is a new variable in cars, which is the list above. And then there you can see it leaves it open, but indentation in loops is important. So it can't be, like I can't do like print car right here and then hit enter. You know, it says right there, indentation error expected, an indented block. So I'll go ahead and try that again. For car in cars, and then I'll just do a tab, and I will do print. I'll print a little message. The car is a, and notice I add a space after and then I'll do plus car because that is the variable that I declared right there. So I am creating a new variable which is then used within the loop, and then I'm passing it the list cars. So I say the print the car is a space plus car, and I'll make sure that they are capitalized, and then I'll do title, close off my print statement, hit enter twice, and then you can see it just printed each one of the cars in the list capital. So it went through, and I can do that again. So I could do just to kind of show you that variable thing real quick, and actually I'm going to make this a little bit smaller, and I'll say for vehicle in cars. Same thing, print I'll say I want a new, almost forgot my quote, new vehicle, and then I'll even do title. I'll add a little statement to the end, this year. Hit enter, and then there you can see. So now I just used a different variable, vehicle, but I had to call that vehicle, that variable, in the loop. we will zoom in over here. All right. So again, right here it says for, which is how I start my loop, vehicle, which is the new variable that I declare and is going to be assigned each value of our list. And then I use that variable right here. So this is a reference to that variable, and then our list of cars is what we're actually passing in. So it is going to be passed in each item, each element of the list, passed in and assigned to the variable vehicle, and then this entire statement is ran against each element in our list. And that is a for loop. All right, so then we could also do nested. So if you remember, I also did a desired car variable, and I made that equal to Bronco. So I will do the same thing. So for car in cars, and for this one, what I want to do is say, I'm going to do an if statement. If statements are a little difficult to do outside of a for loop, I feel, in infrastructure scripting, just because it already needs to be defined. So it would have to be like if, you know, I want to go through all the items, so I could say, actually here, I'll get out of this one and I'll say like, if desired, I'll create a empty list called wanted, and there I just created an empty list, and I say if desired car is equal to Bronco, and it's saying if this condition exists, then do something. So I will say wanted.append desired car. And again, you don't need an else or an if-else statement. So there's my if statement. Now let's go ahead and take a look at print wanted, and let's see if it added it. And it did. It added the Bronco to the list because it was equal to the string Bronco. All right, so we could also do if desired car is equal to Bronco. Actually, I'll do a not equal to. Not equal to Bronco. Print I don't want that car. So you can see I messed up on the print statement. Car. And then you can see it brought me back because now I've got to do an else, and I'm going to say print I do want a plus desired car dot title. Then I'll end my print statement, and you can see it executed and says I do want a Bronco. All right, so back to the original example I was going to do is that's for car and cars, and now I'll do another nested statement. So I still had to tab over, so I'm going to do if desired car, or I'm sorry, if car is equal to desired car, and I've got to do a double indentation, and I'll do print I want a new space and plus car, because I'm looping through each item in our list and then passing each item into the if statement. So if car is equal to the desired car, then it's going to print I want that car. And I will end that, and else print I do not want a car. I'll do title, even though I didn't do a title on the one. So the car that I want is not going to be it's not going to be capitalized. But let's go ahead and run that and see what happens. All right, so it looped through each item in the list, and as you can see, it gave each one of them a title and said, I do not want a Mustang, I do not want a Camaro, but at the bottom, it did match the desired car, so it printed out, I want a plus, and then it says Bronco. So that's a little example of some nested loops. So as you can see, it's really about kind of getting in here, learning your operators, because we could also do a... let me print out the cars again real quick. Okay, so I'll do a sport car is equal to Mustang. And we can do for car in cars. If car is equal to desired car, print I want a new space car title, and we can do an else if car is equal to sport car, print I would consider a plus car dot title, and then else print I do not want a plus car title, and let's go ahead and run that and see what happens. I would consider a Mustang. I do not want a Camaro, I do not want a Jetta, Civic, Malibu, and then at the very end you can see it says I want a new Bronco. So we passed in the item of our list and assigned it to the value car. And actually I'll go ahead and open this up. All right. So we did the same thing, and here is where we started our for loop, for car in cars, colon to start the actual loop, and then we needed to indent, and then we've got an if statement, else if, and else. Each one also ended by a colon. And then some more indentation. So we said if car in our list of cars, if car is equal to, that's explicitly equal to desired car, which we have set to Bronco, then it's going to print out I want a new car.title, and then we called it again here. If it's equal to this new sport car variable that we declared, print I would consider a plus car, else print I do not want a plus car. So you can see everything tied together in this nested loop. And then this is where it actually printed the variable car. Not the variable desired car, not the variable sport car, not our list cars. Each one was assigned that variable and ran through the if statement. Okay, let's go on to another one here. So again, we're going to get into modules and importing different modules, importing different packages. So we saw earlier that I installed the request module, or the request package, I apologize. So if I wanted to actually use that in my code, what are the other ones I did? I did netmiko. I could also do like pretty print. That won't work on that one. Actually, yes, it will. So let me add in my Harry Potter characters again really quick. So I'll add in my Harry Potter characters, and if I print them, you can see it prints it in one line. So if this was a very long dictionary, it could, I mean, a dictionary can be so big that it can fill up an entire screen and multiple pages of an entire screen. But this is quite short. It's still, although I wrote it nice and pretty, it's still printing it in one line. So there is a way to see it formatted, and that is using the pretty print function. So I'm going to do a pretty print, and we will do Hermione. Now, they just made this change recently where I used to have to install the pretty print package, but now I believe it comes with it comes natively with Python 3. So let's see if I even need to import it. All right, so yeah, it says pretty print is not defined. So what I can do is I can import the pretty print module, which I do know I no longer need to install the package. But like I said, that was just an addition, I guess, because pretty print is used so much. Like I started getting those reports not last semester but the semester before. So I'll import the module pretty print, or pprint. All right, so there it took, and now I will do the exact same pretty print command again against Hermione. Ah, dang it. So, yeah, I was worried it was going to do that. Because it's seeing this as a dictionary, and if this was JSON, it would just work a lot better. So we'll just keep in mind on the import modules, I was just hoping we would be able to get that. I don't have some code ready or a JSON object ready at this moment in order to fully demonstrate pretty print, but we will be using it later in the course. But as you can see, it did not take until I actually imported the module. And before that came natively, you would have to use pip, and you would have done pip install pretty print. I'm not in the bash terminal right now, I'm in Python, so that command would not even work. But you used to have to do that, now pretty print just comes with Python 3. Okay, but what I wanted to get to here is I'm going to import this module called random. And what random allows me to do is assign, so I'm going to do rand range, which is the method that I want to call from the random module. I'm calling the method rand range, and we are going to cover methods and modules in the next lecture. It's all contained in your book in the same chapter, but I wanted to give you time to practice these, the data sets, data types, and play with the variables so that you can become more familiar with it. I do feel that Cisco crammed way too much into that one chapter, and they should have gone a little more detailed and split it up. So I decided to go ahead and split it up in the course. But I'll do number equals random.randRange, which is a method from the random module, and then I'm going to give it a range of 10, so that's going to be the highest number it can go. And what I've just done there is I've created a random integer. So if I do a print number, all right, it chose 3, but I can run my I can redeclare my variable, And now if I print number, because it's at the random, right? Did 3 again. It might need me to do another one. It should have thought would give me, it does. So it gave me 3 twice. That was just a coincidence. So it might even give me 4 twice. It's a random number, but I said it needs to be in between 1 and 10. Yeah, so there it gave me 6. And that's the purpose of the random module, if you will. Called the module right here, and then dot the function, and then I passed in a value of 10, which if you actually look at the documentation for this method, a method is a function, but we'll be covering that next week. So this method, I passed in an integer of 10, which is saying I don't want to go any higher than 10. Oops. Oh, crap. Did I lose it? Oh no, did I? Oh, I lost my connection. Sorry about that. No big deal. All right, so we were at import random, and then I did copy, paste, and print number. It shows the number 9. But what I was going to do right now is, I could go up to 100, and then I can even do print number 39. There's a reason I only went to 10, because I'm about to demonstrate a while loop, and to demonstrate a while loop, I'm going to use the input function. So for example, just to demonstrate that function real quick, that is built in. It's not one that we don't need to import input. So it's I'll do first name equals input, and this means I would like input from the user. And I'm going to even give the user a nice little message, and that is, what is your first name? And then I'm going to do a space right there. I'll hit enter, and now you can see it says, what is your first name? So I will say Sheldon. And if I print first name, it took my first name. When you're actually displaying stuff to the user like that, you can also do, I believe it should be that. That wasn't what I wanted. Okay, let me try that one more time. I think I have this backwards. There it goes. So I had to pass in the /n, because that is the character for new line. So as you can see, here it had me put my name next to the message, but let's say I wanted whatever I input to go underneath the message that's displayed to the user. I could just do that. So now I just type in Sheldon and print first name. You can see it took Sheldon. All right, cool. Never use the input to accept passwords, because you'll notice when I did this, this is what I was talking about in the lecture on the slides, is it is actually showing me what I am typing on the screen. So now if I print, well, it's going to actually print my name, but let's say I did secret. What you would want to use is, actually, I do need to import getPass for that. That is another built-in module, so I'm going to import getPass, and then I'll do secret equals getPass dot getPass method, and please enter your secret. And I will do a new line. It says, please enter your secret. So I'll go ahead and enter in a secret. And you can see it did not display anything to the screen. But if I print secret, this is held in memory. In memory means in RAM. random access memory. If you've ever built a computer or you're looking at RAM specifications, as I'm in this Python interpreter, anything that I do is taking up space in memory. But you can see print secret, this is a secret. So if you're wondering like why that's not a security issue, it's because it only exists in memory. The second I enter out of this Python environment, that's going to disappear whenever the script stops working, errors out, or completes. It also is erased from memory. So the important part is that you saw like it does not actually show you what is displayed, what you're typing on the screen. Really just needed to emphasize that. So what I'm going to do now is I'm going to create a quick little guessing game. And in defining a variable here, user number equals input, I am thinking of a number between 1 and 10. Guess the number. So we still have our, oh, I was a little too fast with it. Actually, no, I wasn't. Sorry. I am thinking of a number between 1 and 10. Guess the number. So I'll guess number 8. And then I can say, while user number is not equal to number, then I would do user number equals, because I want to assign the value again, would be input. Sorry, that is not the number I am thinking of. Try again. And I'll display that message to the user. So I've already given it an initial number of 8. If this was ran as a script, that would have been, you know, the random number would have been generated. This would have been displayed to the screen. The user enters a number, and then it hops into the while loop, and it checks whether or not what the user entered is equal to the random number that was generated. If it's not, it is going to ask the user to try again, letting them know that they did not get the correct one. So I gave it an 8. We do not know what the random number is right now. Let's see if 8 was correct. Sorry, that is not the number I'm thinking of. Try again. So, okay, I did not get the number right. So I'll enter 1. Nope, that's not right. 2, that wasn't it. 3, 4, 5. This is why I only did 10. 6, 7, 8, wow, 9, and 10. What? Do we have number still defined? Okay, well, this just shows you created an infinite loop on accident. So I'm going to do a Control-C to keyboard interrupt and get out of there. Let me print number real quick. I thought we had it generated. It was 1. Okay, let's try that again. Number equals... And then while user number is not equal to number, user number is equal to input. I'll just make the message shorter. Try again, please. Try again, please. All right, let's 1, 2. It is not matching correctly. I am sorry, guys and girls, students. I don't deal with while loops very often, and that should not be working. So, let me just try the word. So while user number not number does it not like. Okay, I've got a syntax error. I will get this corrected and give you another example of a while loop, because this worked when I tested it not too long ago. Yeah, it might have been because I ran it as a script, but I will take a look at that. And then I believe that is about it. I just wanted to do one more on you know, like I'm going to create my Harry Potter characters again, and then I'm going to create my list of Potter characters. And then I could do I'll do magic in Potter characters. So now I've got a list of dictionaries, and I'm going to do print and I will do magic, and I'm just showing you how you can kind of filter out dictionaries from a list of dictionaries. So I'll filter out first, and then I'll do title because it's a person, and I'll say plus space is a character in Harry Potter. What did I miss? What did I miss? What did I miss? Oh. And there you can see it still looped through our list of dictionaries and pulled out the first name and gave it a title. Lot to take in, I understand that. Like I said, in your book, this is actually, it's a very short chapter. That's why I cannot recommend more that you get yourself a second book supplement. I really recommend Automate the Boring Stuff with Python, because each chapter goes over a different package that you can use to automate almost any type of office work. So it's really cool. There's also one called Python Crash Course, which I also really like. It goes through theory first, and then it actually has you create different projects, such as making a video game with Python, creating graphs and charts and things like that. So it's all pretty good. So I'm going to go ahead and deactivate this environment and list it. And I'm going to remove FSCJ, recursive, and forcefully. Actually, back out of here, clear, list, and I'll just go ahead and remove mod 2 altogether, recursive force, list, and I can see that mod 2 is gone. Awesome. So that is your example of Python. Really hope you took a lot out of it, and the main thing is get in this interpreter and just start working with it. One of the first things I was told when I started with a programming language, like I said, it's a journey. It takes a long time, so you've got to get creative. Think of things that you would want it to do for you. If you actually look at the history of computers and applications, originally, like even at banks or some of the early corporations that required computers for their employees to work, such as accountants and things like that, all of their applications were written so that they had to enter in information into a terminal. So that is still an application. Once you start to grasp that and get that down, that is when you can start throwing graphical user interfaces over things and giving things a nice little pretty picture, you know, creating web apps and such. So that ends your tutorial on Python. I hope you enjoyed it. If you have any troubles or questions on the lab, please don't hesitate to reach out and ask. Thank you very much for your time. Have a good week, everyone. All right, so in summary, we've gone over an overview of Python, the Python interpreter, Python packages, and how we can use those packages to reuse code or code that other people have written already in order to perform some specific functions. We've gone over virtual environments, how they're used to keep our code more lightweight, our projects lightweight, and they also allow us to create that requirements.txt file so that people can recreate the project as well, build it on their own, and contribute to the project. We've covered the different variable types, which are also available in your book. There's tons of other resources out there. I really recommend that you just kind of get into the Python interpreter and start playing with Python, start experimenting with it. That's why I have you go through certain tasks in Python and throughout this course multiple times, because I'm trying to instill into you that you need to practice and develop that repetitive action in order for it to stick in your brain a little bit better. We've gone over lists, the different ways that we can structure a list and their use cases, dictionaries, key value pairs, how we can add to those and call different items using their keys, tuples, which are essentially immutable lists that cannot be changed, specific built-in functions, how we can use those functions and pass items into the functions. Again, we'll be creating our own custom functions here in the next module. If, else if, and elf conditional matching, for loops. We've covered some nested loops, so where we've nested if statements within our for loops. While loops, for when a condition exists, the loop continues to execute. And then we've also gone over a brief demo where we've taken a look at the Python interpreter and some example code that I have had written. And I really do encourage you to get into that interpreter and continue to practice. So really the only way you're going to develop any proficiency with coding and with any of your IT skills is to continue to practice. The more you practice, the better you get at it. And you're just going to increase your skills and your IT toolbox. And then finally, we moved into our summary. If there's any questions, I do ask that you direct them towards this module's discussion board. If chances are, if you have a question, someone else also has that question. So good area to go. Otherwise, if you're uncomfortable with the discussion boards, even as much as I encourage you to use them, you are welcome to shoot me a text, day or night. It does not matter. I'm never ignoring you, even if I'm busy at the time. I promise that I did see it, and I will get back to you as soon as I possibly can. So with that, I leave you to the labs. I do want to re-emphasize that as you complete each item, so because I had a couple of students reach out, as you complete an item, a lab, that will then unlock the quiz, the next quiz. When you take that quiz, that will then unlock the next lab. When you take that lab, that will then unlock the next quiz. And the whole goal for that being, I do apologize for getting some of the material out at last minute. I really wanted to make sure that the DevNet book was introduced this semester because it came out last semester, so I didn't want to run with the old material when I now have a hard copy book that I can also give you to reference. So I really wanted to make sure I got the book out, and I had to make a few adjustments, such as, kind of moving the labs a little bit around and make the material more match up with what is in the book. But that means that my hope is that once I do have all the material out, if you want to, you can start to work ahead, but you have to complete each item in order to unlock the next item. So thank you, and I hope you enjoy this module's labs.